सर आपकी आवाज नहीं आ रही।
Thank you. So, should I say it again or? Okay, the last class we discussed, Zoya, we discussed what is NMR spectroscopy, how it works, how the protons spin and create a magnetic field around it. And when you put them in a bigger external magnetic field, they split up into two sets of energy level, and then they absorb radio waves and flip to the higher energy level. And that part of energy from the radio waves, when you collect them in the form of NMR spectrum, is missing. So that appears in the form of peak in NMR spectrum, which helps us to determine the structure. Today we are going to see NMR spectrum kya hai and how it helps us to determine the structure and how it identifies the different peaks. NMR spectrum precisely, if I see, it's a graph. ये एक graph है, kind of, look at this. It's a graph जिसमें के दो axes हैं, right? एक x axis and एक y axis. Look at this. ये ग्राफ होता है जिसमें x एक्सिस पे y एक्सिस पे तो क्या है, एब्जॉर्प्शन है, और y एक्सिस पे क्या है, इट इज अ केमिकल शिफ्ट वैल्यू. इट्स अ केमिकल शिफ्ट वैल्यू. ओके, absorption and chemical shift value. Now, what is chemical shift value? And the unit is part per million. I'll explain in a while. But first, let's come to that hydrogens give the peak now. So I'm just putting it aside on purpose. What is the chemical shift value? Okay. Hydrogen gives the peak. So my question is, every hydrogen has a unique single peak, or no, they can have the combination of the peaks or something like that. That's what we have to see. For example, if I ask you, there is a compound known as ethanol. If I ask you, in ethanol, there are 3, 5, 6 hydrogens. How many peaks? 6 peaks in an MR spectrum? Because we learned in the previous section that the hydrogens are going to give the peaks. No, that's not the case. The case is that all the hydrogens which are present, now listen carefully, in the same chemical environment, they are going to contribute to one peak. Same chemical environment का क्या मतलब है वो देखें. मिसाल के तौर पे, if I talk about these 3 carbons, look. The first carbon on the left side, if I talk about this, there are 3 carbons, there are 3 hydrogens attached. Look, 1, 2, 3. Obviously, they are attached with 1 carbon. So they are going to have the same chemical environment. Precisely. एक ही घर में रह रहे हैं, kind of. So obviously they are in the same environment. And the other 2, so they are contributing 1 peak. The other 2, which are present on the next carbon, they are living in another house. They are the neighbor of this, but they have their own house. So they have their own peak. They have their own peak. And that peak would be different from these 3 hydrogens. Because you can think of, कि वो भी तो carbon के साथ ही attached है. That's not the case. They are attached with the carbon, but that carbon has oxygen next to that one, I mean on the right side. But this carbon has a carbon on the right side. There's nothing on its left. So these two, what I'm trying to say that every carbon is actually different from the other carbon. So the hydrogen attached with every carbon has their own chemical environment, so they're different from other. But एक ही carbon पे जो होते हैं वो obviously they will contribute to one peak. They will contribute to one peak. So कितनी peaks होगी इसकी? 3, sorry, और पहला इसकी in these 3 hydrogens 1 peak, these 2 hydrogens 1 peak, and obviously the last one which is attached with oxygen. वो तो है ही, नजर ही आ रहा है कि वो different है, तो उसकी अपनी एक peak होगी. So total number of peaks कितनी होगी? If ethanol is run in NMR spectrum or NMR spectrometer, how many peaks is going to go? 3. और इनकी height जो होगी, इनके area of the peak डायरेक्टली प्रोपोर्शनल होगा. डायरेक्टली प्रोपोर्शनल का मतलब होगा कि फर्स्ट एक बड़ी पीक होगी जिसके ऊपर 3 लिखा होगा, यानी इट इज कंट्रीब्यूटिंग, इट इज फॉर हाउ मेनी हाइड्रोजन्स? 3. देन 2 होगा एंड देन 1 होगा. Yes, so area of the peak is directly proportional to the number of hydrogens contributing towards that peak. So keep in mind, so it is always the same, right? So keep in mind, so ethanol has 3 peaks. And why 3 peaks? Because at 3 different environments, the hydrogens are, so therefore 3. So a number of hydrogens contributing towards the first peak, 3, then 2, then 1, and they are always written on the top of that peak. So ये जो number written होता है, that represents the number of hydrogens contributing towards that peak. Is it clear now? Clear है? So this is how you look at the NMR spectrum, right? Now the next point, if I ask you, okay, one more thing, for example, if let's say there is methane, how many peaks for methane? Obviously there is one carbon, all 4 hydrogens are attached with that carbon. So kitni peaks hongi? There is only 1 peak. And how many hydrogens contributing? Okay. Similarly, if I have 1, what about this ethane?
So 2 peaks.
2 peaks. Why 2 peaks?
Because
there are 2 different carbons. But if you look at them, these 2 carbons are exactly the same. They are exactly the same. Don't you think so? This CH3 and this CH3, they are the same. Because इनके एक कार्बन के साथ 3 हाइड्रोजन अटैच हैं और वो आगे नेक्स्ट CH3 है, तो इसका भी तो यही केस है. आप कहते हैं they are exactly the same, so they can't have 2 peaks. These 6 hydrogens, they contribute to 1 peak.
Because they have the same chemical environment.
Yes, because if you look at these 3 hydrogens, तो ये कार्बन के साथ अटैच है. Who is in their neighbor? CH3. Now look at these 3. ये कार्बन के साथ अटैच है. Who is in their neighbor? So they have the same neighbor, same chemical environment, so they contribute to 1 peak. So now, before we practice that, one thing, coming back to this one. Now, what do you think कि ये जो peak है उसकी ये placement कहाँ होगी? ये जो x-axis है वो क्या है? Chemical shift value क्या है? Right? Now let me tell you. What actually we did, please pay attention. ये जो hydrogens हैं, ये जो protons हैं, they absorb, क्या absorb कर रहे हैं ये? रेडियो वेव्स. सो आप कहते हैं कि ये एक्स एक्सिस पे तो फ्रीक्वेंसी होनी चाहिए ना रेडियो वेव्स की, बिकॉज दे आर एब्जॉर्बिंग रेडियो वेव्स. बट एक्चुअली में क्या हुआ? नो, लिसन केयरफुली. फॉर एग्जांपल, आई अज्यूम कि दिस इज अ एनएमआर स्पेक्ट्रोमीटर. हियर इज द रेडियो वेव्स वाला लैम्प. आई एम जस्ट ट्राइंग टू इमेजिन थिंग्स. इट्स एक्चुअली नॉट लाइक दिस. हियर इज द रेडियो वेव्स वाला लैम्प व्हिच इज प्रोड्यूसिंग व्हाट? रेडियो वेव्स. Now, if I apply an external bigger magnetic field here, let's say, right? And here we have to put the sample, right? And then here we have to collect the spectrometer, NMR spectrum. Let's say if we place methane here and we switch on this light, how many peaks? After passing through all this, जब ये spectrum पे पूछेंगे how many peaks? 1. Because all these 4 hydrogens in the same chemical environment. So what we do actually, instead of doing it like this, हम क्या करते हैं? We do not place methane directly. Because when we place methane directly, just for the sake of analogy and understanding, I'm saying, because it is just like scratching the surface. There is a lot of chemistry behind it, but I can't explain all that. I have to be in my syllabus. So I'm just scratching the surface. So for that matter, I'm trying to make things easy for you. For example, you just imagine, can I ask you to take out your one hair from your head and put it on the weighing balance and tell me the mass in grams or in kgs? You say, oh, that's too less. In kilogram or gram, if I take the mass of one hair particle, I think that's too less. Similarly, actually, we were supposed to measure the frequency of the radio waves that have been absorbed by these protons, the methane. But as the frequency absorbed is too less to measure in hertz, the frequency unit. So what we did, we solved this problem just like we did for the atoms. Okay, we were not being able to take the mass of an atom, so we took the relative mass of an atom. Instead of taking it in grams, we took the relative mass. क्या मतलब है relative? हमें उन्हीं atoms में से एक atom लिया जिसका mass सबसे कम था, जिसका mass was smallest, right? वो atom कौन है? Hydrogen. फिर उसके हिसाब से we compared the other. Helium was twice or 4 times heavier than hydrogen. So helium was 4 times heavier than hydrogen. तो उसका mass क्या आ गया? 4. Carbon was 12 times heavier than hydrogen. तो उसका mass क्या आ गया? 12. यही काम हमने यहाँ किया. We just took a compound. Yes, that is known as TMS, tetramethylsilane. That compound is this: silicon having 4 methyl group attached. So if you look at the chemical environment, CH3, who is the neighbor of CH3? Who is the neighbor of CH3? No, silicon. Who is neighbor of this CH3? All these 12 hydrogens, they contribute to one peak. And because of being neighbor of silicon, which is a unique atom, not normally found in organic chemistry, they would give a unique peak from all other organic compounds. So first we passed the radio waves on putting TMS here. And then when the radio waves come out in NMR spectrum, they give a huge peak. Why it's a big peak? How many hydrogens contributing towards that peak? 12 hydrogens. Then in the follow-up, we placed methane. And then methane 4 hydrogen give a peak here. So now we measured this thing. Okay, जो TMS की peak थी, उससे कितनी लेस फ्रीक्वेंसी की रेडियो वेव्स इसने अब्सॉर्ब की हैं, और लेस पीक किस यूनिट में? पार्ट पर मिलियन में, यानी 1 टाइम 10 टू द पावर -6. लेट्स से आई अज्यूम कि ये 1 ppm है. दैट मींस इन वर्ड्स व्हाट आई एम ट्राइंग टू से कि द मीथेन के 4 हाइड्रोजन्स ने 1 पार्ट पर मिलियन लेस frequency of the radio waves absorbed की है as compared to the frequency of radio waves absorbed by TMS. Frequency of the radio waves absorbed by TMS क्या है in hertz? मुझे नहीं पता. Frequency of radio waves absorbed by methane वाले proton in hertz मुझे नहीं पता. मुझे पता है 1 time 10 to the power -6 parts per million less frequency of the radio waves was absorbed by the methane proton as compared to the proton absorbed by TMS. This is called chemical shift. The distance between the peak of proton and the peak of TMS, right? So ये ऐसा ही है. मैंने अरीस को यहाँ खड़ा किया और कहा कि तुम्हारी हाइट ली, मतलब, और साथ आपका नाम क्या? अवैस को साथ खड़ा किया. अवैस was let's say 2 inches taller than अरीस. अरीस की हाइट मुझे नहीं पता, अवैस की हाइट मुझे नहीं पता. हाँ, मुझे ये पता है कि अवैस is 2 inches taller than अरीस. Or if I stand with Aris, so I'm 1 inch shorter than Aris. Similarly, we can put the Lelma in the order. So Aris is the reference. So usse kaun kam hai, kaun zyada hai. But in all these cases, now coming back to my point, organic mein jitne bhi hydrogens hote, they all absorb the frequency less than. So there'll be no peak after this area. In this area, they all absorb the frequency less than the frequency absorbed by TMS. So उन सब की इससे पहले इससे पहले पहले आएगी। और एक और अच्छी बात ये हुई कि 13 पार्ट मिलियन, यानी 13 पार्ट पर मिलियन, 1 से 13 पार्ट पर मिलियन तक की रेंज आई। ठीक है, ऑल द हाइड्रोजन, राइट। सो इसलिए हमने किया ये कि अब आप कहते हैं यार हम तो स्पेक्ट्रम देखते हैं, वी नेवर सॉ, हमने किया ये। नाउ लिसन व्हाट वी डू, वी रिमूव दिस पीक फ्रॉम द स्पेक्ट्रम, दिस पीक, and we put a mark of 0 over there. So in NMR spectrum, what we do, we put a mark of 0 here. So where there is a 0 mark, that means the peak of TMS is there. And then 1, 2, 3, 4. Don't think कि ये नेगेटिव होना चाहिए, ओके? एक्चुअली तो नेगेटिव होना चाहिए, बट क्योंकि वो सारे कम है तो हमने इस साइड को पॉजिटिव ले लिया। करते करते द मैक्सिमम जो आया वो क्या है, 13 part per million. And this thing is known as chemical shift. The definition I'll give you. Okay, but now you understood what is that? Yeah. So every time when you measure the NMR, what do? You just put this reference compound first, and then follow up में वो डालते हो, और फिर वो जितना उससे difference है वो। अब now, do we have all this data? Yes, we have already collected all this data, and let me show you this data. Right, this is given in the data booklet. Now you'll be given with your exam. Look at this. Look at this. This is the data, bacho. And you are not supposed to learn it. It is given. Look. What this data says? A typical proton chemical shift value relative to TMS. Or TMS ka peak ka aega? 0. So you always think like this. This is the spectrum. Iska 0 yahan 0 nahi hai. Iska 0 is here. Okay? Now TMS की ये peak आ गई जहाँ 0 है. Look at this. वो कह रहा है if you have an alkane in the form of CH3, CH2 or CH or next to alkane, तो क्या वैल्यू आएगी 0.9 से 1.7. So ये 1 है, ये 2 है, तो somewhere here. Got it? If you have alkyl next to CO, यानी CH3O but next to C double bond O, यानी C double bond O के साथ अटैच है, या CH2O या CHO, तो कहां आएगी पीक? 2.2 से 3 के बीच में, here somewhere. Similarly next to O या aromatic जो होगी वो 3.2 से 4 होगी. Similarly triple bond, double bond, benzene. अब यहां तक तो वो है जो नेक्स्ट टू वो कार्बन के साथ अटैच हाइड्रोजन है, राइट? ये उनकी पीक दी हुई थी. बट देन देयर आर सम हाइड्रोजन्स व्हिच आर द पार्ट ऑफ द फंक्शनल ग्रुप. फंक्शनल ग्रुप में भी तो है, जैसे एल्डिहाइड फंक्शनल ग्रुप में भी तो होता है, वो 9.3 से 10.5. अल्कोहल फंक्शनल ग्रुप में भी होता है, फिनोल फंक्शनल ग्रुप में भी होता है, कार्बोक्सिलिक एसिड सबसे हाईएस्ट यही जाता है 13 तक. Then alkyl amine 1 to 5, then amine 3 to 6, then amide 5 to 12, right? No, they are overlapping with each other. So we'll see how precisely we have to figure it out, but they are overlapping. The ranges are overlapping with each other. But that's the keep in mind. Okay, every hydrogen has a unique value where it gives that peak, and this data is going to help us. Okay, so now we are going to do a practice in which I'll ask you to first assign how many peaks and then look at the chemical shift values as well. So that's why I would like you to take the picture of this thing because you need it. I won't be able to show it again and again. So I want you to take the picture of this here. इसकी picture ले लें. Maybe a little blurry, but picture लेके zoom in करोगे तो I think it's gonna. You have to take the picture because I'm gonna give you a question based on this. Have you already done? Okay.
as quality you scroll this way. So please on the graph.
Good.
No, sir. Scroll down. So can you just scroll down a bit where you have drawn the graph?
Graph?
Yes, sir.
Just give me 1 minute. ईशान इसको प्लीज ऐड कर दीजिएगा जो भी मैंने भेजी है इसको प्लीज ग्रुप पे डाल दें सारे ग्रुप्स पे डाल दें okay now Wes we are gonna put it on the group.
Yeah, so can you go to the graph? Yes, sir. So I just wanted to ask you that why they take the values in positive, right? Like 0, 1, they go from right to the left.
Uh-huh.
Why?
Because they don't want to be a negative thing. They took a...
No, sir. Yeah, that actually. But why did the scientists go from left to right? Is there any specific...
Because they were absorbing the frequency less than the frequency absorbed by that thing. And in order to remove the confusion, they don't put a negative sign to that. But actually, 1 part per million means 1 part per million less frequency of the radio waves absorbed as compared to the radio waves absorbed by TMS. So that makes sense. That's why we're putting it on the left side. Okay, now please you have to follow this table with me. Please. Look at this. Okay, please look at this table. Compounds, peaks, hydrogens contributing, and chemical shift. You can either do it in the form of table, or you can just simply write a compound and then put in the values there. Okay, let's start. First one is the methane. What do you think? 1 peak. How many hydrogens contributing towards that peak? 4 hydrogens contributing towards that peak. What is the chemical shift value? 0.02. No. Just look at the data. Yes, anywhere between 0.9 to 1.7. What about this?
1 peak.
How many hydrogens contributing?
6.
6. And what about the chemical shift value? Again, it's an alkane or neighbor of an alkane. Carbon attached with the hydrogen, so 0.9 to 1.7. Again, are they the carbon attached with the hydrogen, all of them? Yes, they are. What about the environment? How many peaks?
2 peaks.
Why 2? These 2 methyl, they are exactly the same. So all 6 hydrogens contribute to 1 peak. So what about this? 6 hydrogens contributing to 1 peak. So what about the middle ones? In 2 की 1 peak होगी. So 2 peaks. And the ratio, this is called ratio thing. What is the ratio? 6 ratio 2. 6 ratio 2 means 6 hydrogens to 1 peak and 2 hydrogens contributing towards the 1 peak. Now what is the chemical shift value? वो दोनों की ही एक ही range में आएगी. और दूसरी की भी 0.9 से 1.7. Okay? Now I would like you to lead. So I'm 4, 5, 6 लिख के draw करके दीजिए please. लिख के draw करके please. Four, 5, 6 with the chemical shift values and number of peaks.
So in the ratio, how would we know that which one comes first? So can I ask you a question?
Yes.
Say the proton, the ratio is 6:1:1. So sir, how do we know that which ratio comes first?
That's no problem. No, yeah, that's because when you draw the peak, na, तो वो number ऊपर लिखा होगा. Okay, number 4, Aries. Kitni peaks? 3 peaks. These two CH3s, they are contributing towards one peak. 0.9 say 1.7. This center wala CH attached with the carbon will be contributing to one peak. CH के hydrogen जो आपको ऊपर जो data दिखाया था, they are there. So क्या होगा? This is next to O ना, जो next to O होता है वो 3.2 से 4 बोला है बच्चे, 3.2 से 4, और OH का खुद अलग पीक होगा, that is 0.5 से 6 के बीच में, I think anywhere between 0.5 to 6. So 3 peaks होंगी और ratio क्या होगी? 6:1:1, यानी 6 hydrogen toward 1 peak, 1 hydrogen and then 1 hydrogen. Right, anyway, 1:1:6 or 1:6:1 or anything. Number 5. Thelma, are you struggling to find the pH, the chemical shift value? Okay. Yes, go ahead.
So there will be 3 peaks.
3 peaks?
Yes.
What about the first one, this one?
First, second,
The value.
Yeah, 0.9 to 1.
Chemical shift value somewhere between 0.9 to 1.7. And what about this?
What should be 0.5 to
3.2 to 4. And what about this? 0.5 to 6. What about this 6?
So the 3 peaks, then again 0.9 to 1.7.
These 6 hydrogens contributing to one peak.
Yes.
0.9 say 1.7. What about this?
The 1 peak, next peaks, and the value is
3.2 to 4. And the last one? 0.5 to 6. Okay, 7, 8, 9 बच्चों. Please give it a shot. बोलना नहीं है, करके दें. 7, 8 and 9. 7, 8, 9, 10, please.
uh,
7 to 10, all of them. Yes. ये पेज या पेज का नंबर Okay, 7.
Peaks.
No, 7 has 1, 2, 3 peaks. The first one has the value of, what about the second one? 0.9 to 1.7. What about the third one? Next to halogen, Joel.
Isn't it CH3 isn't it 3.2 to 4?
No, CH3 alkane is 0.9 to 1. Next to halogen. What about this next to halogen?
So I have not done that, so I cannot open the sheet.
I think it's AR or something. I think it's given. Halogen or something, I believe.
Sir, 3.2 to 4 भी है एक
Yes,
value.
here it is, 3.2 to 4. Why couldn't you find this thing? You see next to oxygen, next to halogen.
That's alkyl.
That is alkyl. Isn't it the alkyl?
Yes.
You see, this is the alkyl, but next to Cl. 3.2 to 4. Yeah. So how many peaks? 3 peaks with the ratio of 3 to 2. Okay. What about this?
So 0.9 1. It's a 2 peaks. Sorry.
0.9 to 1.7.
And then again.
This one is 2.2 to 3, or yeah, 2.2 to 3 next to C double bond O. And the last one, the aldehyde wala. 9.3 to
10.5.
10.5. This one, all three are the same chemical environment?
How many peaks does it have? 2 or 3?
3. You are missing the third one, the aldehydes one.
They are attached with only one carbons.
Sorry?
There isn't, aren't they attached with one carbon? Like one carbon with one edge? Both the green one and the red one.
No. That is the one that is attached with C double bond O. And this CH is actually CH. So we have to see every hydrogen that is looking different. That is attached with different carbon must be different. Until they don't look like ये दोनों CH3s की तरह. वरना हर नए कार्बन के साथ जो हाइड्रोजन अटैच होगा वो डिफरेंट होगा. Would be a different environment. ठीक है. So usually तो जितने कार्बन होंगे उतने environment technically होना चाहिए. But वो कभी कभार जैसे दो CH3s हैं, they got the same neighborhood. Okay, then they could contribute to 1 peak. 9, 2 peaks. ये वाला 0.9 से 1.7, and what about the OH? 0.5 से 6. What about 10? 10 has only 1 peak, Mr. Aziz. Both CH3s contribute to 1 peak, and 3.2 से 4 because the neighbor of CO.
Only 2.2 to 3 नहीं होगा क्योंकि
neighbor of CO is 2.2 से 3.
alkyl next to C double bond O.
Yeah, that one. वो कितना?
2.3 से 3.
2.2 से 3 तक. Okay, my apologies. What about this one?
Sorry, 2 peaks.
2 peaks, because these two CH3s contribute to 1 peak, and these two CH2s contribute to 1 peak. So value is 0.9 से 1.7 for this, or 2.2 से 3 for these. Okay. What about this?
3 peaks.
0.9 to 1.7, then 2.2 to 3, and then C double bond O के next है ना? C double bond O के next है, और ये 9 to 13 C double OH. Yeah, that's 9 to 13. This one is CH2 next to C double bond O. This is CH2 that is next to C double bond O. Okay, this one is actually 2.2 to 3. What about this? Again, these two have 1 peak, 0.9 to 1.7. This has 1 peak, 2.2 to 3, and this has 9 to 13. All the benzene hydrogen are in the one chemical environment. So all these 6 hydrogens contribute to 1 peak. Or 6 to 9 है मेरा ख्याल है उसकी chemical state value. In this, the OH ये 4 एक जैसे environment में हैं. Yes, ये 6 to 9 हो गया बीच में. और ऊपर फिनोल वाला दिया हुआ है शायद, वो देख लें, और मिथाइल वाला 4.5 to 7, और मिथाइल नेक्स्ट टू एराइल जो है AR, वो क्या होता है नेक्स्ट टू AR? 2.2 से 3 है मेरा ख्याल है ना? CH3 नेक्स्ट टू AR एरोमेटिक, दूसरा है या तीसरा आई बिलीव, है ना? 2.3 to 3. And the last one, TMS. We know what is the TMS peak? 0, right? So that's all. Next day we'll see the splitting. Thank you.